Hello everybody, this is Eric Sullivan. We are going to be doing some matplotlib work this time, but we're going to be doing so with an eye towards animation. So why would you want to do animations first and foremost? So a couple of reasons. One, if you've got a function that's defined in terms of time, the best way to look at it, or at least one good way to look at it, is to watch it as a movie. You just let time play. That's an animation. A second one is if you've got a function that is dependent on several parameters, you can actually animate across the parameters and see how the parameters interact with each other. So the first tool I'm going to show you is an interactive tool. So it's a little bit less of an animation. It's something that you actually play with using the ipywidgets library in Python. And we're going to do two examples. So let's jump in here. I'm going to import NumPy, and I'm going to import matplotlib. Just as I normally would, get everything started here. Okay, and then I'm going to say from ipywidgets, import interactive. And interactive is the tool that's going to allow us to do interactive plots. Now, on this first example, I have this a times sine of bx. We're going to do this, let's just say on the domain 0 to pi. So I'm going to set up the domain. X is np.linspace. You could do in a range here. That would also be perfectly fine. 0 to 2 times pi, and let's say 100 points. So this is 100 points from 0 to 2 pi. Okay, now the A and the B, I don't actually know yet. And what I want is I want control over those. So I'm actually going to create a tool that has sliders for A and B that I can play with. And I do that by first defining a function. So that function is going to take A and B in and output a plot. So I'm going to define my function. I'm just going to call it plotter. It takes an A and a B in, and the output of this thing is going to be the plot that we want. So the y values on this plot are going to be the A times sine of B times x. And this is going to be this x up here. Everything's going to be on 0 to 2 pi. Then I'm going to use plt.plot, just like I do with matplotlib for any other plot, x comma y. Let's put a grid on that dude. One thing that is a really good idea, if you've got a function that is actually dynamically changing the scale, you want to fix the scale so that the scale's not the thing that's animating, the function's the thing that's animating. So I'm going to go like -3 to 3. That should be more than enough. And then plt.show. So this function takes an A and a B in, outputs a plot. So I can demonstrate that the function works by just sending in, let's say, an amplitude of 1 and a B of 2. And if I run that, Control Enter to run it, I get my plot. Now I didn't put labels on here. I'll leave it up to you to pause the video and put an X label, a Y label, a title, all that stuff. All right, but you see that this actually works. I can change this to a 3. And I should see 3 cycles from 0 to 2 pi. Change it to a 4. I see 4 cycles from 0 to 2 pi. Change the A to a 2. I should see an amplitude of 2. Okay, so this does work. But that's not actually what I meant by an interactive plot. So I'm going to define, I'm calling it iplot just for name, interactive plot. I'm going to define this, this variable iplot as an interactive. The interactive is going to call on the plotter function. And then what I do is I take the 2 parameters and I tell it what range to give it. So the amplitudes, let's take those from -3 to 3 by, say, 0.1s. The B's, let's take those from 1 to 5 by, let's say, 0.5. And then I'm just going to call on that interactive plot. So this line of code defines the interactive plot, or actually the interactive plotting tool. And this last line calls the interactive plotting tool. Okay, so I've run it. Now I have 0 right in the middle here, so 0 shows up in the middle of the slider. And an amplitude of 0 is going to have, well, no amplitude. But I can now grab that slider with my mouse and move it. And if you let the lag happen a little bit here, it lags a little bit because the computation is not happening locally on my machine. This is a Google Colab document. The computation is happening elsewhere. But I have a way that I can explore the behavior of A and B and see the relationship between the two. Okay, so this is kind of nice. I've got a little bit more fine-grained control. If I come in here, I can actually type in individual values if I wanted to, and the individual values can be any number I want them to be, and it'll actually plot them just fine. Well, it has to be within the range, of course. Sorry. Okay, so this is, scrolling back up here, plotting across parameters using ipywidgets. Now, the next example, I'm going to plot this function, 3 minus e to the minus t over 2, as a function of time, and it's going to be kind of in the same idea. So the imports are all the same. For the sake of some really clean and complete code, I'm just going to copy all of these dudes. Okay, and I'm going to set up my time. Now, this is time, so I'll do it a range this time. 0 to, I don't really care, something big, let's say like 5. And we'll take kind of small steps. Times from 0 to 5 by steps of size 0.1. Okay, I just did that because I did a linspace on the previous one. It's good to be flexible with the two types of domains you could set up. Now, on my plotter, my plotter tool this time, I need to take in the time step. Right, that's actually the thing that I'm going to take in. So, excuse me, it's going to be like time step 0 would be 0, time step 1 would be 0.1, time step 2 would be 0.2. I'm starting from here going by 0.1s. So if I take in the time step, I should then be able to get out my function. So my function value, y, is 3 minus the exponential function, exp, of t evaluated, let's see here. I want everything from the beginning up to that time step. And then divide by 2. Because that was the function we were dealing with. See, right there we had to divide by 2. Okay, now if you're a little muddy on this, let's actually plot it. And I'll just show you what I was actually intending to do here. So if I do plotter of like 10. Ooh, I got an error. Well, shoot, what did I get? X, Y, must. Oh, oops. It's not X. What am I doing? This should be time of everything up to time step. There we go. Okay, sorry about that. Sometimes it's good to make errors on live TV here. Okay, so I should have done the first 9 time steps because remember, well, I'm sorry, the first 10 time steps, 0 through 9. So that would have been at time 0, 0.1, 0.2, all the way up to, and here I've got 0.9. So if I did plotter of 11, now I've got all the way up to 1, the first 11 time steps. If I did 100, ooh, okay, so now I've got that. Okay, so this is what this function looks like over the time steps here. But I didn't want this to just be something like this. Let's define an interactive plot. I'm going to call on my plotter function again. I'm just using the plotter name as a dummy variable. You can call it whatever you want. Okay, so my time step, I'm going to say from 1 to, now I took my times by steps of 0.1, and sometimes it gets a little bit murky as to figuring out exactly how many things are in here. So what I'm going to do is just say length of t, and just leave it, and then call off my iplot. So now what I can do here is come back to the beginning. All right, there's time step 1. Now notice this is a really funky little grid. It doesn't actually show me anything. And if I advance that a couple of time steps, okay, now it shows me some more here. So maybe I should do plt.xlim is 0 up to 5, which was my maximum time. And now it's actually fixed. I should probably set my y-lim also, because notice that the y-axis is changing as I do this. So let's set my y-lim. And let's set that from 2 to, oh, I'm sorry, from -10 up to 3. It looks like that's where everything is falling in between. Now I've got something where the axes are not going to change, and I can play with time as the parameter, and I can see how this function evolves over time. Now, remember, it will lag just a little bit because the computation is happening elsewhere. That's perfectly okay. It just takes a little bit of getting used to get comfortable with the fact that it is going to lag a little bit. And of course, I can crank it all the way up to the very end. And then the one last thing I'll do is I'll say, well, what if I took smaller time steps? Okay, notice it says time step is 250 now. Okay, so if I go in really small increments, I'm going to see very tiny changes in the plot. Okay, now you can make these interactive plots as complicated as you want them to be or as simple as you want them to be. The two that I've showed you here are relatively simple, but they work. And these are actually reasonably easy animations.